So our team has built the largest man-made chemical molecule thus far in history. It's over 300 million molecular weight. It's the chromosome of a bacteria. We started with 4 bottles of chemicals and have replicated the entire genetic code with some variations of a self-replicating bacteria.
What people are saying about this is that this is the first entirely human-created, self-replicating organism. Is that a correct assessment of what you've come up with?
Well, not quite. We don't have the self-replicating organism yet. If you substitute chromosome or genome for organism, that is the case. Our challenge now is to get this chromosome to boot up in a cell and actually create a new life form.
A new life form essentially created by human technology. Some people find that scary. What do you say about that?
Well, anytime there's major changes in technology, it can be scary, and we acknowledge that. We've been trying to deal with the public concerns and ethical questions before we did the first experiment. We've had, back in the late 90s, we had a 1.5-year-long bioethical review that the group doing it published in Science in 1999, saying they thought we were taking reasonable approaches and should proceed. Everybody is obviously concerned with, in this modern age of potential terrorism, with any new technology, and we have to acknowledge that and work to avoid it.
What possible benefits does this have for humanity?
Well, right now our initial goal for doing this was to understand the basic cell biology, how a single cell could work, how it could have evolved, what genes are essential for life. But we've been working on these issues now since 1995 when we decoded the first genomes in history. And we realized that these techniques could totally change how we approach science and engineering in the future, basically creating the opportunity to engineer organisms based on the genetic code in the computer to put them at a man's will. The main areas we're approaching this with right now are what we consider the most critical problem on the planet, and that's taking oil and coal out of the ground and burning it and putting it in the atmosphere. So we're trying to create 2nd, 3rd, and 4th generation biofuels by creating synthetic pathways right now in existing cells. In the future, we will design these organisms in the computer to deal with the tremendous efficiency potential of biology to replace fossil fuels.